I'm going to show how to find the asymptotes of hyperbolas, but I have to do this quickly because 7th period is out to lunch and I have to finish before they're back. So let's see. I already tried making this video once and I failed 100 times. I made so many mistakes, I said let's redo it. I'm going to go through like 4 different problems. And I'm going to start off finding the asymptotes. I'm going to graph it a little bit to find the asymptotes, but that's not a necessary step. I'm going to, with each problem I do, I'm going to try to get a little faster and try to show you how to think about it and skip some of the steps that are unnecessary. Starting off though, I'll graph it just to show kind of the intuition behind the process. This is going to make a hyperbola that has a center at 1, -2. And to graph it, I'm going to first draw my box. I'm going to draw my vertices and covertices. So in the x direction, oops, already messing up. In the x direction, I'm going to move 4 because 16 is 4 squared. And because that's below, oops, that's below the x. So in the x direction, I'm going to move 4. From the center, I go 4 to the right, and 4 to the left. Similarly, in the y direction, because 9 is 3 squared, in the y direction, I'm going to move 3. Go 3 up, 3 down. Those are my vertices and covertices. I use these to make a box. And the important thing about this box is that it tells me where my asymptotes are. My asymptotes are going to cut through the diagonals of this box. One asymptote is going to look like that, and the other asymptote is going to look like that. I could finish graphing the hyperbola now, but I really don't have to. I found my asymptotes, and this video is about how to find the equations of the asymptotes. This is the graph of the asymptotes. Now I need to figure out the equations. I'm going to figure that out using the point-slope form for a line. I'm going to find the slope of each asymptote and a point that goes through, and then use point-slope. So, let's see. It looks like this line has a slope of it rises 3 and runs 4. So it looks like it has a slope of 3 over 4. And it looks like this goes through the point 1, -2. Not it looks like, it does. It goes through that point because that's the center, and the asymptote's going to go right through the center. So if I have a slope of 3/4 and I have the point 1, -2, I can use point slope form of the line. That looks like y minus y1 equals m x minus x1. And I can fill it in with my information. Y minus -2 equals 3/4 x minus 1. And I can clean that up to look like y plus 2 equals 3/4 x minus 1. That's one of my equations for my line. That was my line with the positive slope. That's this line. You can convert it to slope-intercept form, y equals mx plus b form. I don't see a need to. A line is a line, so that's fine. But ask your teacher. If you're not my student, go ask your teacher how he or she wants it. The other asymptote, this asymptote, goes through that same point. It goes through the point 1, -2, but this time its slope falls 3 before it runs 4. So this time it has a slope of -3/4. After I plug that point and that slope in, it's going to create the same equation as before, but the slope, instead of 3/4, it's going to be -3/4. So I'm going to end up with y minus y1 equals -3/4 x minus x1. I'll do it here because I don't have time to make the video again. those are my two equations. That's one asymptote. That's the other. Let's do it a little faster. That was 5 minutes. Say I start off with this equation. I need to figure out, okay, so if I had a graph here, I would start off with the center. The center would be at 0, -6. And from that center, in the y direction, I'm going to move 5 up and down. 5 squared is under the y, so 5 is how much I move in the y direction. I'm going to move 5 up and 5 down. And in the x direction, I'm going to be moving 2. 2 to the right, 2 to the left. And I'm going to use those to create a box. And my asymptotes are going to be the diagonals through this box. So even without a graph, I can already tell stuff about these asymptotes. I can tell that this asymptote has a slope of, it rises 5 and it runs 2. So it has a slope of 5/2. And this asymptote passes through the center. It passes through the point 0, -6. So if I use my point slope form, and I do y minus y1 equals m x minus x1, I have my equation. And the other one, this asymptote, is going to be the exact same deal, except it's going to be a -5/2 slope. It's a slope, it's the same line, but just in the negative direction. So it's going to have this equation. That was 2 minutes to find the asymptotes, not bad. But I don't even really need to bother drawing this silly picture each time. I can just think in my head, I'm going to go up by however much I get from under my y, and I'm going to go to the right by however much I get from under my x. So I could just look and do what number am I going to get from y over what number am I going to get from x, and that'll give me my slope. And my point is always the center. So that was a lot of talking, not much writing. Let's see if I can write some of that and explain it. For this one, I think to myself, I don't even need to do a box. I think to myself, okay, I'm going to end up with a slope. In my box, I'm going to go up by 3, because that's the square root of what's under the y. And I'm going to go to the right by 8. This is 3 squared and this is 8 squared. So I'm going to go up 3/8. So my slope is going to be 3/8. And I'm going to pass through the center. The center is -7/5. So one of my asymptotes, the one with the positive slope, is going to be y minus y1 equals m x minus x1. That's it. Found an asymptote. The other one's going to be the same thing, but with a negative slope. I found my asymptotes. Do that again. That was I think 1 minute. Not bad. My slope, I'm going to go up by my change in y. This is square root of 5 squared. So my box is going to go up square root of 5, and it's going to go over 10. So my slope is going to be up square root of 5, run 10. I'm going to pass through the point 2, 1. So my line is y minus y1 equals m x minus x1, and also that asymptote that has a negative slope. That's how you find asymptotes of hyperbolas. This video was a little bit all over the place because I'm making it quickly during lunch, but I hope that helps. If you're my student, good luck on the quiz this week.